As we begin this lesson's video notes, let's check and make sure that your paper is headed correctly. On the first line in the left-hand corner, you want to write today's date. I am not writing the date because I'm making this video at a different day and time, but if you'll write today's date in which you're taking these video notes. On the right-hand side of the same line, please write your first and last name. Your class number and letter may either go right beside it or may go on the line right above it. The lesson title should be the second line, immediately underneath the date and name. Today's lesson is lesson 13-1, which means it comes from chapter 13, and it's the first lesson in the textbook. You can see in the textbook, in the left-hand corner, chapter 13, lesson 1, and this is going to be about solid figures and nets. On my paper, once I have the title, I'm going to skip a line, and I'm going to go up against the left-hand margin, and I'm going to write number 1 for problem number 1. When I take a look at lesson 13-1 in the textbook, the first 2 pages are just descriptions of what solid figures and nets are. So I'm going to go ahead and turn the page, and number 1 is actually on page 342. So here are the instructions for problems 1 and 2. Number 1 says to classify each polyhedron, and then to name all faces, including bases, edges, and vertices. So even though this is just one problem, there are going to be several things that we include. The first thing that number 1 asks for is to classify the polyhedron. I know number 1's a polyhedron because it's 3-dimensional. All of the faces are flat. They have no curved edges, and it's a closed figure, which means it's not open. Number 1 has one base. The other triangular faces rise up to meet at the top vertex. That's called the apex. When I see this shape, I immediately think of a pyramid. Now, what type of pyramid depends on the type of base. You could technically argue that this base is a rectangle or a square. But because there are no lines that indicate that all of these edges are exactly the same length, I'm going to go with rectangle instead of square. So number 1, I'm going to call a rectangular pyramid. And once again, it's called a rectangular pyramid because the base is rectangular and the triangle faces meet at an apex at the top. Now the next part of the problem asks me to name all the faces, including the bases. So underneath the name, I'm going to go ahead and write faces. There are 4 faces that I see in my shape. I apologize, there are 5. I see 4 triangle faces around this pyramid, but I also see a face on the bottom. Let's start with that. That's the base, and it's in the shape of a rectangle. So the symbol for that is actually a rectangle. And I will name it using the vertices that make up this rectangle. So A goes to B, B goes to C, C goes to D, and D goes back to A. So I could call this rectangle A, B, C, D. They're the 4 vertices, and they're in order of how they connect to one another. I could have called it B, C, D, A, or even gone backwards, B, A, D, C, as long as I wrote them in an order in which they actually connect. Now that's just one face. It's just the bottom base. I also have 4 triangles that make up the side faces around this pyramid. So I'm going to mark those with a small triangle to signal to me that these faces are triangular shaped. I'm going to start here. I'm going to write them in the order in which they connect to one another. A, B, E. The triangle on this side, B, C, E. The triangle on the back side, C, D, E. And the triangle on the left-hand side, A, D, E. Once again, I could have written these vertices in different orders as long as they correctly attach to one another in the order in which I wrote them. So we just completed the faces. We did the rectangular base and then the 4 triangular faces that just wrapped around the side. The third step is to name the edges. So I'm going to go ahead and label my work with the category edges. And edges are the lines where the faces meet. So I'm just going to start with the base. That's the easiest place for me to start so I don't forget edges. I'm going to start line segment AB. And line segment is represented by a little line above AB. Then going around the base is line segment BC, so that's an edge. The back is CD. The left-hand side edge is D to A, or you could call it AD, as long as that symbol's correct for line segment. So those edges go around the base, but then there are 4 edges that come up and all meet at this apex. So I'm just going to start with AE, line segment AE. Line segment BE. Line segment CE. And line segment DE. So we have classified our shape. We've named all the faces, including the base. We've listed the edges. And the last step is to list the vertices. And those are just the points where the faces and edges meet. So I see A, B, C, D, and E. 5 points on my pyramid. And I don't need a symbol because it's not a face. I don't need a line segment symbol. It's just a point, so it's just the regular variable. All of this is the answer for number 1. Problem number 2 has the same instructions, and I can tell by looking at it, it's not going to be quite the same as number 1. For number 2, the first thing I'm going to do is I'm going to classify this polyhedron. I know it's a polyhedron because the edges are straight, no curves. The faces are flat, no curves. It's a three-dimensional shape. It's a solid. Whereas this shape was a pyramid, this one's not. And we can see that visually because the sides don't come up and meet at one apex. This, therefore, is a prism. And prisms have two bases. Typically, they're not the rectangles. They're typically the smaller shapes on either side. This shape here and this shape here are my bases, and they actually are rectangles. So number 2 is classified as a rectangular prism. So notice the immediate difference between 1 and 2. They're both rectangular, but one's a pyramid and one's a prism. Our second step was to name the faces. And this time, there are two bases because it's a prism. So there's a base here and a base here. They're both rectangles. So I'm going to use the symbol for rectangles. And I'm just going to start with the one closest to me. I could call this rectangle FBCG, or I could start GCBF, as long as I go in order of somehow the way they connect. So let's start with G. And let's call it rectangle G, F, B, C. And then the second base that's parallel to this and it's congruent, so it's the exact same size, is rectangle, maybe we start with A this time, A, D, H, E. There are more faces. Those just happen to be the two bases. I've got 4 more rectangles that wrap around the middle. So I'm going to go ahead and put the symbol for rectangle again. I'm just going to start with the front piece, A, B, F, E. Then if I move to the top of my shape, E, H, G, F. Continuing over the shape, I have a back piece, D, H, G, C. And this piece on the bottom, if I've worked my way up and over, is A, D, C, B. So what I found was I had 2 bases that were rectangles. That's what made it a prism. And then these rectangles in the middle that connect the 2 bases, I have 4 of those as well. Our instructions asked us to list the edges next. And we represent those with line segment symbols. So let's just start. Let's see, we've got to find a good place where we don't lose track of our edges. Let's just start here at the bottom. A, B. Then maybe I'll work my way up. B, F. Then if I work back over, line segment F, E. And coming down, line segment EA. So that was just kind of this front face. Now what if I do the line segments on this face? All right, I have FB, but that's already in my list. BC I don't have yet. CG, yep, I don't have that one yet. GF, okay, that's a new one. I don't want to repeat a line segment I've already mentioned. Okay, so there were just 3 that I had not already used. I'm gonna have to shift my paper just a little bit. So that we can continue our discussion about edges. So we did this face and this face. Let's do the edges on the back face. GC we already had. What about line segment CD? And then D to H is a line segment. And then H to G. All right, so there were just 3 on that back that I did not have. I'm going to move to this side face. H to E, that's a line segment. Line segment EA, I've already got. Line segment AD, I don't have yet. And then DH, that's a new one. Oh, nope, I've got it right there. So you can see here, it's going to be extremely important to go back and count the edges to make sure you got them all. So I had 4 on the front, 4 on the back, and 1, 2, 3, 4, 4 connecting them. So that should be 12 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm good to go. I'm going to erase that last comma. I have my 12 edges. The last step is to name all of the vertices. After naming all those edges and try not to get them mixed up, it's going to be a relief just to label the points. A, B, C, D, E, F, G, H. So there are 8 of them. And they don't have a symbol because they're literally just the points or the vertices where those edges and faces meet. I should have 8. And so I have labeled the vertices now of number 2.